Hey people, it's Mr. Thompson with a video math lesson in a series on probability and statistics, this time particularly with statistics, on a type of diagram for data called stem and leaf plots. Alright, so let's get it right into it and let's just look at what a stem and leaf plot looks like. Okay, it's kind of this T-bar graph type thing. Okay. And over here we have our stem, right? And then over here we have the leaf, okay? Or leaves, I don't know, whatever you want to call it. Stem and leaf, hence the name, okay? So, and then a stem and leaf plot is always going to have a key, all right? And it's going to say something like this. One number and then a line and then another number means 13, okay? So, what this is telling us is that these numbers kind of pair up with that number on the left. Okay, the 1, the 4, and this 4 kind of go in with this 0, and these ones go along with the 1. Okay, and as this says, 1 and 3 means 13. Okay, so 0 and 1 would just be 1, right? So we have a 1. 0 and 4 is just a 4, and then we have another 4. Then we have 13. We have 14, right? We have two 16s. Okay, and then we get all these other ones as well, right? 21, 25, 26, 27, 32, 33, and 33. Okay, those are all the numbers we have. That's basically this diagram represents all these numbers, okay? And you'll notice that it's in order, right? It's always smallest to largest from the inside out, from the left to right in this case, right? 1, 4, 4, 3, 4, 6, 6, 1, 5. It's in order, and then this goes in order as well, from smallest to largest. And the reason we do this is it's pretty simple. It's pretty easy. It kind of cuts down on, you don't have to write these digits over and over again, though, right? You just write them once. But we also get this visual interpretation of the data. Okay, these numbers, when they're written out, even in order like this, you kind of have to look at them and go, okay, how many of these are there? How many of those are there? When you look, how many 10s, how many 20s, how many 30s? When you have them in this format, they make a really nice visual sort of thing, and you can see, oh, okay, there's 4 in the teens, 4 in the 20s, not as many in the 30s, and maybe not as many in the ones, right? Less than 10. Okay. So, and with different sets of data, you can tell just by looking at the graph what, some different things about it. Okay, and we'll look at a couple of examples, some pretty simple examples of that kind of thing. Really quickly, this key is really important because it could say something like 1 and then a line with a 3 means 1.3, okay, for example. In which case, that would change what these numbers are, right? That would mean there was kind of a decimal point where this line goes, right? 0.1, okay? 0.4 and 0.4, and then 1.3, 1.4, 2.5, right? So on and so forth, okay? To 3.3. So it's very important to pay attention to what this key means. Sometimes there might even be another decimal afterwards or something like that. It could mean 1, 3 could mean 130, or who knows. Anyway, that's one type of problem you might have. You might be shown a stem and leaf plot and asked to write out the numbers, okay? Or it could be the other way around. And there's another example, another way to see stem and leaf plots is if they're back to back. So we'll look at an example here where they're back to back and how that's useful, okay? So this time we'll be given numbers, and these are going to be some numbers that are points scored in 10 basketball games. I'm going to swap that. 10 basketball games. There we go. That looks better. Okay, back-to-back stem and leaf plots. Okay, and we're going to have two players here, Samantha and Akila. And let's say over the course of 10 basketball games, we recorded how many points they scored, okay? So there's 10 numbers for each girl here, and it's just however many points they scored in that game, okay? So first let's just look at just Samantha, okay? And let's make a stem and leaf plot for the points that Samantha scored, okay? So if we look, the lowest, we want to go in order here, so the lowest number we've got is 4, okay? So the first digit in that is sort of a 0, so we can put a 0 and then a 4, all right, on the other side of the line. And we'll put our key in later to say that this means 4, right? Then we've got 6, 2 6s, a 7, and an 8, okay, that also go in this column, right, because they're also in the ones, right, less than 10, okay, so 6, 6, 7, and 8, all right. Then we've got 10 and 2 12s, 10, 12, 12, okay, so we're going to put a 1 right here, okay, and then a 0 for 10 and 2 2s for the 12s. Finally, she scored in a couple of games, she got 21 and 22, right? So we put the 2 here, which means 21 and then 22, okay? And we can put we'll put the key later. That was Samantha. Now we want to I'm going to add a whole nother side to the stem and leaf. I'm going to add basically another set of leaves, another leaf over here, keep the same stem, okay? And what that allows us to do is directly compare these two data sets, okay? So we'll go through the same process with Akila. Okay, she got, and we'll label these, okay, of course, so Samantha and Akila. Akila got, once she scored 8, and once she scored 9, so those go in this line here, so 9 and 8, and then she also scored 14, 15, 16, another 16, 18, and 19, right? So we put that in the teens. 4, 5, 6, 6, 8, 9, okay? And then she also got 20 and 22, okay? So we'll put those in the 20s, 2 and 0. You'll notice that every single number in a stem and leaf plot, in the leaves here, is a distinct number, right? The 2 and the 0, this might look like 20 right here, but really it's 20 and 22, right? Now we want to make our key. All right, and so we can just pick any one of them here. 1 and then 4 means 14. So for example, 1 and 4 means 14. 1 and 0 means 12. 1 and 2 means 12. 1 and 0 means 10. 1 and 2 means 12. Getting ahead of myself. Okay, and now this allows us to look and kind of compare, and we can really quickly and easily compare what's going on here. Okay, and what you want to look at, you can look at the shape of the numbers that go on. If you're kind of recording them all the same size of the numbers and things like that, and you're careful about that, then the shape of your graph will automatically come out to kind of give you an idea of what's going on. So Akila has this nice symmetrical data. She's got a few up here, lots here, and then a couple up in the 20s, okay? Symmetrical data. So it means she was really consistently in the teens. She got some high scores. She got a couple low scores, but mostly she was doing pretty well, okay? We call this, because it's this symmetrical shape, right? We call that symmetrical data, okay? Samantha, on the other hand, has more of a sideways sort of shape here. She had a lot of low scores, okay? She did get some in the teens, and she even scored, her high score was the same as Akila's high score, 22. So she's capable of getting, the high scores, but she was not as consistent. She was more often in the lower numbers, okay, scoring just single digits. Now this, because it's not as nice and symmetrical, it kind of just slopes up in one direction. We call that skewed data, and those are just words, to know when people are talking about this stuff. Those are the words they might use. So if somebody says, "Oh, there's some skewed data here," that's what they're talking about. Okay, that it kind of leans over to one side as opposed to being nice and balanced. Okay, so that's all there is to it with stem and leaf plots. Good luck, and I'll see you next time.